In this video, we will pick up where we left off on the t distributions. And so in class this week, we talked about the differences between a z and a t distribution, when to use them. Remember, a key summary is we use t distributions when we do not know the population standard deviation, and we will use the standard deviation of our sample for the basis of our calculations instead. So let's start off with an example of confidence intervals. This example says, presented with recordings of a pair of people of the same sex speaking the same phrase, can a listener determine which speaker is taller simply from the sound of their voice? So in order to study this, 24 young adults at Washington University listened to 100 pairs of speakers and were asked to determine whether they were, which was taller, basically. And so basically this would be the percentage of those correct out of 100 for each of the 24 participants. So everybody kind of had a percent, determined how correct they were to see who was taller of each of those 100 pairs. And we see a lot of results like 65% correct, 61% correct, 70% correct, and so on. Looks like fairly centralized data around 60 to 70%. And let's say we wanted to calculate a 99% confidence interval to determine, what's the average amount correct for a population of adults, and try to answer the question, can an average U.S. Listener determine whether someone is older, and with what kind of level of accuracy are we going to expect? So first of all, we need to know, well, if we're going to find our T star, or our test statistic for 99% confidence interval, we need to know all the things like X bar, S, and so forth. One sec while I get my tablet onto the right page. And here we go. And so we could identify a lot of the common parameters in here, like, well, X bar. Now we could do this in Excel. We could find the mean and the standard deviation with a calculator or whatever else. Excel is probably the fastest. Let's go ahead and revisit how to do this in our calculator real quick. But remember that the degree of freedom is always one less than the sample size, so n minus 1. In our case, we had 24 participants, so 24 minus 1 would of course be 23. And we just remember why we care is in our t-table, this will tell us the proper row to look at. Now, in order to calculate the mean and standard deviation, recall that we can do this using the list feature in a TI-84. And if we go into stat and hit edit, we can just type in all of our data points into L0. So let's go ahead and do that. 65, 61. And then we'll be good to go. I should have done this ahead of time to not make you guys wait on me to type them all in. But we'll be done in just a second. Whoops, I messed one of them up already. And 70. Okay, I think that's all 24. Cool. And then from there, once we have our data stored, we can go back to the main menu. And then we want to go into list math to calculate the mean, number 3. So the mean of L1 will be 62.16 repeating. And the standard deviation of L1 will be 5.81 approximately. So we can go ahead and round this off. X bar will be approximately 62.17 and S will be approximately 5.81. And generally we don't want to round those, like depending on how accurate our confidence interval, how the degree of accuracy with that, we would want to round those less, we would want to keep more decimal accuracy if we wanted more accuracy, but in this case, it's not really specified, so we'll just kind of do what might make sense. Okay, now for the confidence interval, again, we could start off with the formula for such: X bar plus or minus T star times S divided by the square root of n. Remember, it's the same formula for confidence interval. The difference with the T distribution is we are using S instead of sigma and T star instead of Z star. Now we know our sample mean is going to be approximately 62.17 plus or minus. Now we got to make sure to look up T star in our T table. And we know we have a 99% confidence interval, and we want to use the 23rd row. So we go to row 23, and we want to go to 99%, which is the 1, 2, 3, 4, 5, 6, 7, 8, 9th column. So 1, 2, 3, 4, 5, 6, 7, 8, 9 would be 2.807. Times our calculated standard deviation divided by the square root of our sample size. And doing all that, we would get 62.17 plus 2.807 times 5.81 divided by square root of 24. Again, this is going to be a little bit off because I did a little bit of rounding. But the upper end of our confidence interval will be approximately 65.50. And then the lower end, I can hit second entry to copy all of that. And then just change this to a minus. And that will give me the lower end of 58.84. And again, if we had to write this as a verbal conclusion, what we would write is that we are 99% confident that the average percent score for whether a person can determine the basically who is taller amongst the pair of people is somewhere between 58 and 65% accuracy. And what I would conclude is that yes, there is people can tell a difference in some people in a speaker's height based on their voice. Now, it's not 100% accuracy, but it's higher than 50%, which if someone was just guessing, you'd expect around a 50% accuracy. And since, we're 99% sure it's higher than 50% chance, we can conclude that there's some ability to determine who is taller. And, since we know the average height of men is taller than women, we could also kind of make a conclusion about determining the sex of a speaker simply based on the sound of their voice. Again, not with perfect accuracy, but with more than a random chance of a guess.